Right, this is another follow-up video to a recent video. This time this Matsuada, what's the name there, power supply. The model number is on the back. It's an AU-3P400, which means it's a 3000 volt output high voltage power supply. I found a manual for this, but it's for this model, except it's fairly obvious that manual is for a later variant. The internal highest voltage section is clearly different, and the only other external obvious difference is these two controls for setting the voltage and the overcurrent limit. On the later variant, instead of being just normal one turn pots or 3/4 turn, 270 degrees or whatever it is, they have vernier type knobs and they're 10 turn controls. And I had a pile of these sitting around and I thought, no, okay, I can upgrade this, and the trouble is they're too big. They can't get close enough together for the spacing of those knobs, so that idea is out the window. But I can still put in these 10 turn pots. Before I do that, I thought it'd be interesting to see how easily I can set a particular voltage with this knob and then see how much easier it gets with 10 turns. So we'll do that. Okay, I've got nothing plugged into the output. That should be okay, I believe. So turn on the power. Got quite a loud fan on it. And it's in CV mode, constant voltage, because I've got the current knob turned up. And if you go low enough, it goes to CC mode. It's not constant current mode, it's actually a overcurrent cutout. If you exceed the current set by this, the power supply turns off, and you have to reset it either by cycling the output switch or through a reset signal at the back. But for this, we want to see the voltage. Now, I'll turn this up so it's in CV mode, otherwise I couldn't do any voltage. I'll show you that. It was in constant current, doesn't matter what you do here, even with the output on, doesn't matter. So you've got to have that to a certain low limit of current. And it's locked out, so I have to cycle the output. Now we're in CV, and I can turn up the volts. Let's try and get 100 volts first, so 0.1 kilovolts. Bit fiddly, actually very fiddly. There we go. 500 volts. Doable but fiddly. Kilovolt. Okay. 2 kV. Now, why didn't the fourth digit come on? There's 4 digits behind there. I don't remember why that is. Again, getting that last digit is fiddly. 3 kV. So you can get it within, so what's that, 10 volts, isn't it? You can get it within 10 volts pretty easily, but getting it right on is a bit difficult. So, okay, we'll change out these pots. Okay, covers off, taking off the 2 knobs. There's the pots there, but they're a little hard to get to, so I think I'll remove these 4 screws that should let this front plate fall down and make it easy to get to the controls. Right, I don't know why they're so long. They've only got to be a few millimetres. In fact, one of them was shorter than the other 3, but only need to be like 4 or 5 millimetres. Okay, so this should drop down now. Well, or swing out. I'll put my block back underneath. swing up. There we go, that's probably the way to go. I found that swinging up gives us the easiest access to these guys, so yeah, set about replacing them. And we don't need that. And it looks like someone's needed to do this before. I wonder if they were changed from verniers to these. Anyway, we'll replace that when we put it back together, or not. Okay, get the soldering iron out. Now, these guys were done up rather tightly, the nuts on them. I had to use that to get them undone. But that's now done. Now these guys are a little bit tricky in the layout. I mean, it's obvious on these things that the wiper is the middle one, and when you turn it fully counterclockwise for low, the wiper must be against this terminal. But on these, it's not so obvious. In fact, it's the end there that's the wiper, and this one here is the one that's connected to the wiper when you lowest resistance to the wiper when you fully counterclockwise. So wiper goes to that one, this one here goes to the middle, and that to the end. So wire it up. Alright, just a quick check to make sure things are wired up properly before I tighten everything down, put the covers on, put all the nuts back. So power on, no explosions, keep that out of the way, and wind up. We're in CV, so good. I should be able to wind up voltage here. Turn on the output, idiot. This measured, I think, 6 ohms minimum, so we can get down to 0 volts, that's pretty good. Alright, so it increases when I turn that way, going to constant current. Oh, we've got constant current, there's nothing on the output. Well, that was wound right down, so got to cycle the output. Wind this up, so that's wired the right way, I think. And yep, that's looking good. So I'll tighten these, put all the rest of the bolts in, put the cover on, put the knobs on, and see how easy it is to find us a particular voltage there. Still don't know why that 4th digit isn't coming on both of them. They've both got an extra digit out here. Alright, there it is. I'm taking off this irrelevant label and try to clean up a bit. It needs a bit more work, I think. And I'll make the 10-turn pots point downwards rather than there for minimum. And let's see if we can make some volts more accurately. 100 volts. Turn up the C, make sure we're in the CV range by getting that up a bit. Now, output on, dickhead. That's a lot easier. 0.1, and there's quite a bit of adjustment room to move that last 10 volts. Alright, 500. 1000. 1500. 2000. Yeah, it's much easier to set a voltage at least at the 10 volt level. 3000 volts. So 3, again, pretty easy to set. So it's fairly easy to get within 10 volts, and there's enough wiggle room that you can probably even judge a little bit better, you know, like to whereabouts within the 10 volt range you are. Like that's just over 3000, so might be 3001. Go a bit further. Okay, back off. That might be 3009. If I go halfway between those two points, that might be 3005. Anyway, I'm happy with that. And if you don't like this video, why are you watching it? Catch you later.